Hey y'all, I found this question online and it's an SAT question and I got it from the Princeton Review. So let me go ahead and read it to you guys. In the figure below, circle 0 has a radius of 8 and angle x0y measures 5/16 pi radians. What is the measure of minor arc xy? Okay, so that's a lot, right? I mean, I'm overwhelmed. So what's up with this particular question from the SAT is that we're not allowed to use a calculator. So I have to do all of it by hand. So it's a little bit overwhelming, right? It appears to be overwhelming. I mean, it is, right, to an extent. What it's basically asking is for us to find x, y. It wants to find this little piece right here. If this was the circle, all we're doing is finding this piece. There's actually a formula for it. It's 2 pi r theta. Theta is basically degrees. What was in the denominator? Is it 360? Yeah, 360. Cool. So that's the formula we're going to use. We're just going to throw all the numbers it gave us into this little die right here. That's all we're doing. And we're going to have to make some adjustments. So this first part right here, that's circle. That's the formula for circumference, right? Because here's radius. Radius is like half of the line, diameter when it goes all the way across. 2 is because there's 2 radius. This is pi is a circle. This guy right here, inside the parentheses, that is the center angle formula. So how do I capture the angle, right? So we put them all together, we multiply it, and it's arc length formula, I believe. So all we're doing is just throwing stuff in there. Here's the thing. It's giving us radian, right? 5/16 times pi radians. We have to convert it into degrees because the formula requires that because I have theta in the top of that fraction in the numerator. So basically what we're going to do with this problem is step 1, we're going to convert from radian to degrees. And then step 2 is we're going to apply the arc length formula. And then bam, we got the answer, right? So let's try that. Let's so I have 5/16 pi. Anytime you see like the pi just dangling like that, it goes in the numerator. It goes in the top. So, okay, the formula to turn a radian into a degree is radian, which is right here. We just wrote it down. 180 over pi. That's the formula. And if you want to do it the other way, if you want to do degrees to radian, you just flip the numerator and the denominator, right? So let's go ahead and work this out. So I guess we'll have to work it out by hand, right? 180, 5, that's a 0. That's 40, 5, 9, that's 900, right? That's for the numerator. Let's label that n for numerator. But that's the top part of the fraction. So I have 900 and pi because we threw it up there in the top. And then I have 16 pi, right? So that's the answer, but we're going to get rid of the pi's, right? So I have 900 over 16. We got to reduce that. That's too big. There's few ways we can reduce it. I personally just keep dividing everything by half or like a 5 or like a 3. So let's do the half C one. So I'm going to do 450, 8. Looks like I can keep going. Let's do 4. And then this becomes 225. Yeah, cool. So that's the degrees. That's my degrees, right? So it's asking for my radians, what are the degrees? It's 225 over 4. That's what's up, right? Cool. So I literally take this guy and I put it in here in the numerator, the top part of the fraction. So it's going to look like this. R, then I have 225 over 4 all over 360, right? That's the setup. And then, of course, we're going to put an 8 where that little r is. But you know what? I have a fraction inside a fraction. So I gotta work that out. I can't have that. I won't be able to solve it if I don't get rid of that. So let's go ahead and get rid of that. What I'm going to do is I'm going to take apart this fraction. So I'm going to do 225 over 4 times 1 over 360. So the left part is the numerator, which is the top part of the fraction. The right part is the denominator, or the bottom part of the fraction. And we're multiplying it together, which means I just put them together. So that's 225. And then the denominator is 360 times 4, so that's a 0. 4 times, that's a 24. 24. And then that's going to be 114. No, it's going to be 14. Yeah, 14. Cool. That's the denominator. That's the numerator. So it's 225 over 1440, right? That is the what is it called? The center angle, right? This right here is this second part, all that stuff in the parentheses. But that's a big number, man. We got to reduce that. So let's bring it over here. I have 225 over 1440. So we could keep dividing it in half, but we can't do that because it's an even and odd number at the end, right? That 5 and that 0. So I can't just like split it in half. Okay, let's do it in fives. So let's do 5 divided by 225. I'm going to do the same thing with the denominator. I mean, it just seems like this is like one of those long-winded problems that just, I don't know. Okay, let's do 22. It goes into like 4 times, right? So I get like a 20. This is old school. 2, 5, that's a 5. And that gives me 25, which is a 0. Cool. So the numerator is going to be 45. Let's label it n for numerator. Let's do the denominator. 5 divided by 1440. That goes in like twice. I get a 10, which gives me a 4, which gives me a 44. And then that gives me an 8. 8 times 5 is 40. Gives me a 4. Gives me another 0. Bring it down. That goes in 8 times again, right? Cool. So that's 288. That's the denominator. So this is getting messy. Okay, so I have 45 over, what was it? 288, right? And what we're doing is, remember how we put everything in the top, that formula? And then we had to break down the fraction in the fraction? We're still doing that. We're just going to reduce this, and then we're going to have that answer. So what is this, 88? I'm going to have to divide this again. Let's do it by 9s. I'm going to try 9. I don't know if it's going to work in the denominator, but let's try it. So 45 and 9, I know that's 5, right? That's the finger trick. I don't know if you know about that, counting by 9s. Okay, and let's do, that's the numerator. Let's do 9 divided by 288. How many times does 9 go into 28? Like, I don't know, 3, I guess. And then we multiply that, that's like 18, 27. That leaves me with the 1. Oh, sweet, this is going great. Okay, so then I have 2. It goes in 2 times. Cool. So I have 5 over 32. Great. That's what goes in here. Remember how we had a fraction in the top and then like a whole number in the bottom? Cool. So what we're doing, let's erase. Should I erase some of this? Let's erase a little bit of this. Okay. So yeah, we're just gonna go ahead and bring all this down. We're bringing all of this down. So I had 2 pi r plus the new thing that we had, which is 5/32. If you remember, we had theta at the top, and I had to put that new degrees thing in there, which was 225/4. And then I had this whole crazy fraction. It was 225/4, and then all over 360. I had to break that down. So we're going back to the original formula that I was talking about earlier. We broke it down a little bit to make it easier. And now all I do is put everything together. So it's going to be 2 pi 8 is going to be the radius. I got that from here. They told me what it was. I didn't have to work for that. And then it's going to be 5/32. Okay. Anytime you have a fraction multiplied against a whole number, you're going to put an invisible 1 in the bottom or the denominator. So all of these get multiplied together, and then all of these get multiplied together. So let's see. That's going to be 80. 2 times 8 times 5 is 80, I think. 32 pi. Right? That is the answer, but this is the answer, by the way. But we have to reduce it. You know, I can't just have this huge number, so I got to reduce it. I like to just divide everything by half over and over. Let me rewrite it again. 80 divided by 32 pi is, let's see, 40, then 32 is going to be 16 pi, and then that becomes 20/8 pi, then that becomes 10/4 pi, and then that becomes 5/2 pi. Dang. Okay, that is the answer. That is straight up the answer. That was long-winded because they don't let us use a calculator, so I had to do all of that. There's probably a faster way to do it, but this is how I presented the information. So all we needed was the formula called arc length formula, right, which is right up here, this whole thing. And then I had to take this top part, this theta, and I just had to transfer the radians into degrees. And that formula is right over here. So all we did was just mess with 2 formulas, and then we plugged everything in. It would have been like 20 times faster had we had an opportunity to use our calculator. Okay, I hope this helped. Okay, thanks. Bye.